Hi children and viewers. In this video I am going to explain one of the important topic children, that is, so here we have one topic. It is there, can we measure the weight of a body? Can we measure weight of a body? That is our topic for today's video children. So generally we will say that what is mass and what is weight. Oftenly every student or general in common people can feel that mass and weight both are similar, but mass and weight both are different. Clear? So if anybody can ask you what is mass and what is weight, and either both are same or different, so generally common people will say both are same, but we are science students, that's why you have to say what's the mass and what is the weight. So that's why you have to observe the definitions, both definitions you have to observe very carefully. Clear children? Generally mass means it is the quantity of substance. Quantity of substance can be known as mass, and mass always can be represented by the letter M, but weight can W is equals to mg. Weight can be represented by the equation W is equals to mg. There m is the mass and g is the acceleration due to gravity. So now what about weight? Weight is nothing but, on this earth every object is attracted by the earth. So that with what amount of force any object is attracted by the earth, that should be called its own weight. You have one weight, me also want to have weight, and chair is also having some weight. So that means every object on the earth that should be attracted by the earth with certain force, even though when they are on earth's surface, when they are in air. So that's why children, what have to say, weight is nothing but every object should be attracted by the earth with certain force. That amount of force what we call weight of the body. Clear children? So today our topic is what? Can we measure the weight of a body? Yes, we can measure the weight of the body. Already told you what's the formula. W is equals to m into g. So there m is the mass of the body and g is what? Acceleration due to gravity. Children, already I told you the value of g. The value of g is 9.8 meter per second square. G value is 9.8 meter per second square. That is the small g value. Clear? And children, I already told you the value of g can be taken as positive when the body is coming from certain height to the ground, and when the body is going up, the g value should be taken as negative. When the body is falling down, g value is positive. When the body is going up, g is negative. Okay children, now I am coming to the point. So children, in our textbook two activities are there. So here in the first activity, so children, on board you have some diagrams. So children, you must be focused on the diagrams where I am showing. So that's why you have to watch carefully children. So children, here we have two spring balances. So children, spring balance is a device that should be used to measure weight of the body. Spring balance can be used to measure weight of the body. Generally, common balance can be used to find out the mass. Physical balance can be used to find out the mass. Here, spring balance can be used to find out the weight. Clear children? So children, here First here observe the first diagram. So children, you have to observe here, this is the one rigid support. From that rigid support here the spring balance should be suspended. This is the spring balance. Inside what we have, spring it is there. On sides we have some readings are there. Some readings are there. Clear children? So and here the bottom, at the bottom some weight is attached to the spring balance. Clear? This is the weight. So this is what some body is attached. So children, there is one spring balance is there. Spring balance is suspended from a roof. And what I am telling, one body is attached to the lower end of the spring. Lower end of the spring. Then you have to observe here the spring balance indicator. So where I am showing now, it is the indicator. The indicator will show some value of reading in concerned units. So this pointer will show some reading. That reading is the weight of the body. Weight of the body. A spring balance is there, that should be suspended from a rigid support, and lower hook has some weight or some body is suspended from the lower end. Once we are attaching some mass to the lower hook, the spring is stretched down, that should be elongated. When it is stretched, along with that the pointer will come down, and after that initially the mass will make some oscillations. It will oscillate upward and downward, upward and downward. After some time that should be coming to the rest. Once it is coming to the rest, at that point situation the pointer will show some reading. That reading is nothing but here weight of the body. Clear? We are giving mass, we are attaching some mass to the lower end of the spring balance. Then spring balance, already internally some spring it is there. While we are giving mass to the spring, the spring is elongated. Once the spring is elongated, the pointer what it is attached to the spring, that should be comes down, and the pointer will show some particular reading. So here on sides we have some readings are there. Clear? So that value of the particular value should be taken as weight of that particular body. So in this way we can measure the weight of the body. Clear children? And after that children, here where we have one question is there. What's that? When we can feel weightless? When we can feel weightless? So why, even though the body has mass and even though the value of GD is there, but sometimes we can feel weightless, and so every body can become as a freely falling body or weightless body. So to understand that, one activity is clearly given. So generally here freely falling body means when the body is falling from certain height. When the body is falling from certain height, on that body there is only gravitational force acting, no other force acting on that body, then that body will be called freely falling body. Once a body is dropped from certain height, during the motion of the body there is only gravitational force is acting, no other force is acting on the body, then that body will be called freely falling body. For example, you are watching in movies or in television, anything. So while a person is swimming, diving from the diving board into the swimming pool, so this is the diving board, from that he jumps into the swimming pool. When he was in the air, that person can feel weightless. Got my point? Diving board it is there. From that diving board a person jumps into the swimming pool. When he was in air, he was in motion through the air up to what time he was in the air, then he can feel that weightless, because on that person only gravitational force is acting. Clear, children? So generally, how we can identify the weightless of your body? So children, you can observe, while we are dropped a ball from certain height, when the ball is in the air, we can't feel anything. But once the ball can strikes the floor, there should be rebounds. That means what? When the ball is in air, it is a freely falling body. That's why it comes down actually. Once the ball can strikes the floor, it can rebounds again. That means what? When the ball comes down, when it touches the force, then there is some force acting on the ball in opposite direction. Okay, children. So here in our textbook, 2 activities are there to understand the weightless of your body. To understand the weightless of your body, those are very simple. You have to look at once. Okay, children. Same example here. First time what I told you, the spring balance is here suspended from a rigid support. Suspended from a rigid support. Now here we are taking a spring balance. And same thing, the same mass is attached to the lower end of the spring balance. Clear? We are taking a spring balance and we are hold like the in our hand. So when we are hold in our hand and the lower hand is having some mass, then it will have some mass, and the spring balance can shows some reading. That reading is weight of the body. And children, if we can drop this spring balance, from certain height, then the pointer will shows the 0 reading. Got my point? Once the spring balance is supported, having some rigid support, then it will show some reading. When the same spring balance should be dropped from some certain height, during the motion, when it is in the air, the reading shown by the spring balance is 0. That means here it is the weightless body. Once the body is coming through the air, here it will show some 0 reading. Now it is called a weightless body. Even though gravitational force acting on the body, it will show some reading. That's why this body should be considered as the weightless body. Weightless body. Clear, children? So what is the difference here? For the first time we have some weight, it is supporting, it is there. It is suspended from the rigid support. And second time there is no rigid support, it is there. That's why what you have to observe, when it is suspended, there is some force acting on the body. That should be upward force, and downward force is gravitational force. Gravitational force is acting downward, and some other tension force is acting in upward. So that's why we are getting some reading here. Once here it is moving in the air, spring balance can move in the air, then there is no force acting on that one, simply except gravitational force. That's why here there is no reading shown by this one. So that's the difference, children. Here, other than the gravitational force, some force is acting on the body in upward direction. But while it is falling down, only one force is acting in downwards, that is in downward direction, gravitational force. That's why the reading shown by the spring balance is 0. And we have another activity, is the children. So same thing here, we are taken, now it is a children. Now look at the second diagram. We are having, take second term, tray. We are taking some glass tray. The same diagram I am drawing here. This is the glass tray, and we made some holes. Here we made some holes, and after that we are attaching the rubbers like this. We tied some rubbers. Clear? We are taking some tray that should be placed on a table. So this is the one table, horizontal surface I am saying now. This is the table. Clear, children? So it is on the table, and where tray is placed on the table, and we made some holes to the sides very gently, and after that by putting the rubber bands into the holes and we tied like them. After that we are finding like this. Clear? Now if you can keep some object, so here we are taken some object, that object should be placed on the rubbers. Then what you can say, the rubbers are stretched and goes down. Clear? Initially if there is no weight on the rubbers. Now after keeping the mass, certain mass, the rubbers goes to the stretch down. So that means what? Here weight is acting in downwards and normal reaction should be acts in upward direction. That means in downward direction some force is acting, and in upward direction also some force is acting. Clear? That's why due to the weight of the body only the rubbers are stretches down. Clear? Got my point? And now children, if we can drop the same tray into the air from certain height. Clear? So if we can drop we are taken some tray, and that should be having some rubbers as shown in figure, on that we kept some mass. Then initially that should be like this. Clear? Once we can leave that one, then once the tray comes into the motion through the air, we can see the same thing like this. That means here on the rubbers there is no stretching of rubbers. Why? Because when it is in the air, that should be having only gravitational force, and it should be becomes as a weightless body. So this is the children simply about the what is mean by weightless body, and can we measure the weight of the body? Yes, we can measure the weight of the body by using spring balance. And what is the weightless of your body? When the body is in air, that should be acted upon by only gravitational force. No other force acting on the body except gravitational force. Then that body can be considered as freely falling body. So when there is no other force to balance the gravitational force, then it is treated as freely falling body or weightless body. So children, I hope you understand. We will meet in the next video with some other interesting topic. So we will meet you soon. Bye. Take care.